Welcome to the tutorial for solving rational equations. First thing we need to realize is, what is a rational equation? A rational equation consists of an equal symbol between two algebraic expressions. So, it's an equation with an equal sign. The easiest way to look at solving rational equations is to follow the following 5 steps. The first one, factor each denominator. 2, identify the non-permissible values. 3, multiply both sides of the equation by the lowest common denominator, or as I'll commonly refer to it as, LCD. Step 4, solve by isolating the variable on one side of the equation. 5, check your answers. Why do we check our answers? We check our answers to see, 1, if they're extraneous roots. Is the answer equal to the non-permissible value we found in step 2? Is it an imaginary number? Or 2, is the solution reasonable? This becomes very important when we look at word problems. Let's look at 3 examples and work through the steps with each one. First example, x divided by 4 minus 7x equals 3. Let's work down our steps. Factor each denominator. The denominator is already in single factors. There's nothing else to do. Identify non-permissible value. We have x, set x equal to 0, so we know x cannot equal 0. There's our non-permissible value. That was easy for this one. Multiply both sides by the LCD. What is going to be our lowest common denominator here? Well, it's going to be 4x. So that means we need to take 4x and multiply by the left side, and take 4x and multiply it by the right side. Now, as I've written it here, I need to distribute my 4x to everything on our left side. So let's do that. So I have 4x times x over 4 minus 4x times 7 over x equals 12x. Now there's some things that are common. I have a 4 and a 4 in the first expression, and I have an x and an x in the second. So I can rewrite that as x squared minus 28 equals 12x. I'm going to bring my 12x over. I'm going to bring it over, change its sign, set the whole thing equal to 0. Now I'm working on step 4, which is solve by isolating the variable on one side of the equation. So I have x squared minus 12x minus 28 equals 0. I can actually factor this quadratic to x minus 14, x plus 2 equals 0. And now to solve each individual solution, I'm going to isolate out each of these factors. So x minus 14 equals 0, x equals positive 14 is one solution. The next one, x plus 2 equals 0, x equals negative 2 is the other solution. The fifth step is check my answer. Well, none of my solutions equal my non-permissible value, so I'm actually good there. None of these are extraneous for that reason. Let's see if in my check, if my left side equals my right side when we substitute for x in the original solution. Let's see. So I have x equals 14, that's going to be 1, and I have x equals negative 2. So I'm going to substitute 14 for x first. So I have 14 over 4 minus 7 over 14 equals 3. Will my left side equal my right side? Let's find out. I have 7 halves minus 1 half equals 3. 6 halves equals 3. Yes, 3 equals 3. So that works out. X equals 14 is a viable solution. Let's try x equals negative 2. So I have negative 2 over 4 minus 7 over negative 2 equals 3. Negative 1/2 plus 7 over 2 equals 3. 6 over 2 equals 3. 3 equals 3. So yes, both my solutions that I found for x work, because through my check, the left side equals the right side. Let's look at another example, one a little more complicated. 2 divided by z squared minus 4 plus 10 divided by 6z plus 12 equals 1 over z minus 2. So the first thing we need to do is factor each denominator. I have perfect square, so that becomes z minus 2, z plus 2. Can I factor 6z plus 12? Yes, there's commonality with 6. So I take my 6 out, I got z plus 2, and 1 over z minus 2. That's as low as it'll go for the right side. Next thing I have to do, identify non-permissible values. Well, I have x minus 2, I have, whoops, these are z's. So z minus 2, and I have z plus 2. Another z minus 2, so I'm going to keep it as those two. So let's solve z minus 2. Z equals positive 2. Z plus 2. Z equals negative 2. So z cannot equal plus or minus 2. Those are my non-permissible values that I've found. That's step number 2. Let's multiply both sides of the equation by the LCD. I have z minus 2, z plus 2. I have another z plus 2, and that's 6, and I have a z minus 2. So my lowest common denominator is 6 times z minus 2 times z plus 2. My left side is 2 over z minus 2, z plus 2, plus 10 over 6, z plus 2. And my right side, put 1 z minus 2 multiplied by 6 times z minus 2, z plus 2. All right. Now I need to bring in, distribute my left side, and at the same time, then I'm going to start taking out items on the numerator and denominator that are the same. So I have 6 times z minus 2, z plus 2 times 2 over z minus 2, z plus 2. Now, then plus 6 times z minus 2, z plus 2 times 10 over 6, z plus 2. And I'm going to go ahead and start reducing my right side. I have z minus 2, z minus 2. So that leaves me with 6 times z plus 2 on the right side over 1. Now let's do the same thing to the left side. Let's start taking out what's the same. So I have z minus 2, z plus 2. Okay, so that leaves me with 6 times 2, that's 12, over 1, plus z plus 2 and 6. So that leaves me with 10 times z minus 2, and on the right side I have 6z plus 12. So again, I just distributed that already. So let's start collecting our z's on one side and our numbers on the other. So I have 12 plus 10z minus 20 equals 6z plus 12. I'm going to move my 6z over here and all my numbers to the other side. So I have 10z minus 6z. And the reason I'm doing it that way is because I want positive z's. just to make my life easier. And then I have 12 minus 12 plus 20. So 4z equals 20, z equals 5. Well, z equals 5 does not equal my non-permissibles, so I'm good there. Let's do our check. So I need to substitute in z. I keep writing x, so I apologize for that. Z equals 5 into our original. So I have 2 divided by 5 squared minus 4 plus 10. 6 times 5 plus 12 equals 1 over 5 minus 2. So 2 over 25 minus 4, 21. Then I have plus 10, 30 plus 12 over 42 over 1/3. Well, now I need to collect everything. Well, I'm going to use 21 because 10 over 42 is the same as if I divide it each by half, I got 5 over 21. And I can make 3/21 by multiplying by 7 over 7. So that gives me 7 over 21. So let's see, does this equal 7 over 21? 7 over 21 equals 7 over 21? Yes, it does. So that's a check. So z equals 5 is a viable solution. Let's look at our last example. 4k minus 1 over k plus 2 minus k plus 1 over k minus 2 equals k squared minus 4k plus 24 divided by k squared minus 4. Let's factor out our denominator first. So for 4k minus 1 over k plus 2, there's nothing I need to change there. So 4k minus 1 over k plus 2. And k plus 1 over k minus 2, again, nothing for me to change there. They're already at the lowest. I have k squared minus 4 in the denominator. That is perfect square, k minus 2, k plus 2. I'm going to leave the numerator as k squared minus 4k plus 24. Now, you'll see the reason for that later on, just because then I'll be able to collect like terms. So I'm not going to factor the numerator. Figure out my non-permissible values is the next step. So what do I have? I have k plus 2, and I have k minus 2. I'm going to need the other side there for the check, so that's why I'm working on the bottom. I have a k minus 2 and a k plus 2, so those are the only two factors that I have. So I have k equals negative 2 and k equals positive 2. So k cannot equal plus or minus 2. Those are my non-permissible values. All right, what are my LCD? My LCD is k plus 2, k minus 2, because if we look, I've got those in common between the three expressions. So k plus 2, k minus 2. I'm going to do a little shortcut, and I'm going to distribute it as I go. So times 4k minus 1 over k plus 2 minus k plus 2 times k minus 2 times k plus 1 over k minus 2, and it equals k squared minus 4k plus 24 over k minus 2, k plus 2 times k minus 2, k plus 2. Okay, now I can start getting rid of things that look the same. So k plus 2, k plus 2, k minus 2, k minus 2, k plus 2, k plus 2, k minus 2, k minus 2. That leaves me with k minus 2 times 4k minus 1 minus k plus 2 times k plus 1 equals k squared minus 4k plus 24. Now, I have to FOIL the first and FOIL the second. And because I'm going to have to isolate k, I need to have that done. So I have 4k squared minus 9k plus 2 minus. The next part I have, I'm going to keep it in parentheses before I distribute the negative 1. I have k squared plus 3k plus 2 equals k squared minus 4k plus 24. So let's collect out my like terms. I have 4k squared minus k squared. I'm going to bring this k squared over, minus k squared. And then I have minus 9k. I've got a minus 3k, again bringing the negative in here. I've got a minus 4k here, so that's plus 4k. And I'm going to bring the 2's over to the other side. So I have 24. Bring this one over first, right here. So that's minus 2. I have minus 2, so once I bring that over, it's going to be plus 2 on the right side. Now that I have grouped all of my like items, I am going to finish my simplifying to see what I come out with k. So 4k minus k, that's 2k squared, minus 9 minus 3 plus 4, leaves me with, excuse me, minus 8k, and 24 minus 2, I'm actually going to bring the 24 back over and put minus 24 equal to 0, and now I can, to make it easier to factor, I'm going to take out the 2, minus 4k minus 12 equals 0, 2 times, and find my factors, k minus 6, k plus 2. So that means my answer is going to be k minus 6 equals 0 and k plus 2 equals 0. So k equals positive 6, k equals negative 2. So these are my two solutions. Now I need to find out, are these extraneous or not? So let's do our checks. Well, I know right off the bat that I have something that looks familiar. K minus 2, well, that's one of my non-permissible values here. So this right away is extraneous, because k cannot equal negative 2. It's a non-permissible. Can't spell value here. Sorry about that. Non-permissible value. So just by finding my non-permissible values early, that saves me a step of having to check both k equals 6 and k equals negative 2. So now I'm going to do my check for k equals 6. Is that a viable solution? So 4 times 6 minus 1 over 6 plus 2 minus 6 plus 1 over 6 minus 2 equals 6 squared minus 4 times 6 plus 24 over 6 minus 2, 6 plus 2. Well, I guess I should have done 6 squared minus 4. So let's change that on the bottom to the original. So it's 6 squared minus 4. Alright, so 24 minus 1 is 25. Nope, it's 23. 23 over 8 minus, I have 7 over 4. And I have 36 minus 24 plus 24 over 36 minus 4, so that's 32. So that leaves me with 23 over 8 minus 7 over 4, which is equal to 36 over 32. Okay, so I have to have some like items. So I know that 36 over 32 can be reduced if I divide the numerator and denominator by 4. So that actually is the same as 9 over 8. Well, that leaves me with an 8 and an 8, so I'm going to use 8 as my lowest common denominator. So I have 23 over 8 minus 14 over 8 equals 9 over 8. 23 minus 14 is in fact 9 over 8 equals 9 over 8. So that does check out. Therefore, k equals 6 is the solution to this question.